Hello friends, welcome to Achieve Abundant Academy. In the last lecture, we have discussed up to question number 5. So, we will discuss question number 6 onwards in this particular lecture. So, basically, we are discussing the problems on the Serret and Frenet formula. Okay, so what we have seen in the previous set of lecture is that the set of relations involving the derivatives of the fundamental vector is collectively known as Serret and Frenet formula. So, we have the fundamental vectors as T and B. Okay, so we have, suppose this is our curve. So, we have unit tangent vector as T. We have the perpendicular to this is principal normal vector. Perpendicular to T and N is binormal. Okay. So we have how we find this. So we have the right hand thumb rule. We have right hand thumb rule like this. We have this is N and order is in the right hand. Order is with respect to right hand thumb rule, that is anti-clockwise direction. We have T cross N equal to T cross N is equal to B. N cross B. Cross B is equal to T. B cross T is equal to this. We have seen in detail in the last lecture. Okay, so we have set of relations involving the derivatives of the fundamental vector is known as Serret and Frenet formula. It's collectively known as Serret and Frenet formula. The set of relations involving derivatives. So let us take the derivative. We have dt upon ds, db upon ds, and dn upon ds. So these are the derivatives of the fundamental vector. Let us write down here. So we have dt upon ds is kappa n, db upon ds is minus tau n, dn upon ds is tau b minus. These are collectively known as Serret and Frenet formula, where k is called curvature, tau is called torsion. Okay, and 1 upon k is radius of curvature, 1 upon tau is radius of torsion. This we have seen in detail in the last lecture. So let us start discussing the problems. So in the sixth question, we have to find T and B and kappa and tau, that is torsion, for the space curve given as x is equal to 3 cos t, y is equal to 3 sin t, and z is equal to 4t. Let's start solving. Okay, so we have solution of for 6. Okay, so we have the position vector as cos t plus sin t k cap plus 4t k. We have to find kappa and let's solve this. So we have seen in the previous lecture, we have the unit tangent vector t is equal to dr upon ds. This we can write as dr upon dt on ds upon dt, and ds upon dt equal to modulus of dr upon dt. Okay, so let us calculate dr upon dt from here. We have dr upon dt. dr upon dt is minus 3 sin t I cap plus 3 cos t j cap plus 4 k cap. We have ds upon dt. ds upon dt is equal to modulus of dr upon dt. This is equal to 9 sin square t plus 9 cos square t plus, let's take the modulus of this, plus this is 16 the root. This is 9 plus 16 is 25. So root under 25 is 5. So we have the ds upon dt as 5. So let us calculate dr upon dt. Sorry, let us place here. Let us place here in this expression. We have t is equal to dr upon dt upon ds upon dt. dr upon dt is this expression. This is minus 3 sin t I cap plus 3 cos t j cap plus 4 k upon ds upon dt. ds upon dt is 5. We have this as unit tangent vector is given by this particular expression. This is equal to minus 3 upon 5 sin I cap plus 3 upon 5 cos t plus 4 upon 5. This is the expression for unit tangent vector. Unit tangent vector t is given by minus 3 5 sin I cap plus 3 upon 5 cos t plus 4 upon. Okay, so this is the unit tangent vector. Now let us find this n. So we have from the first first expression of the Serret and Frenet formula. So we have dt upon ds is equal to kappa n. Let us calculate dt upon ds. We have dt upon ds. How we can write this? We have dt upon ds. We can write as differentiation of unit tangent vector with respect to time. That is dt upon ds upon dt. ds upon dt is 5. Let us calculate dt upon small dt. This is equal to upon dt equal to minus cos t I cap upon 5 I cap. Okay. This is equal to minus 3 upon 5 cos t I cap plus sin t plus 3 upon 5 cos t I cap plus sin t. This is equal to, and ds upon dt is 5. So this will be equal to minus 3 upon 20 cos t I cap plus sin t j. The value of dt upon ds. This is equal to kappa n. Let us take mod here. We have dt upon ds modulus equal to kappa n modulus. K is the scalar quantity, n is a unit vector. So the modulus of unit vector is 1. This will be equal to, let us take the modulus of this. This will be equal to minus 3 upon 25 cos t I cap plus sin t j mod of this. This will be equal to 3 upon 20. We have kappa is equal to, from here kappa is equal to 3 upon. Let us find, calculate n. We have value of dt upon ds as this one. dt upon ds is equal to kappa times of n. So from there we can find the value of n. We have dt upon ds equal to kappa n. So from here n is equal to 1 upon k, 1 upon k, 1 upon k times of dt upon ds. Let us put the value here. So n is equal to 1 upon k. K is 3 upon 20. This will be equal to 25 upon into dt upon ds. dt upon ds is this one. This is minus 3 upon 5 cos t I cap plus sin t. Okay, this gets cancelled, equal to minus cos t I cap plus minus. Okay, this is the value of n. So let us write down here is equal to, value of n is minus of cos t. Okay, now let us calculate value of b. We have value of b as, so we have order order of t and b is in the anti-clockwise direction, that is in the right hand thumb rule. T, this is, have t cross n is equal to, let's calculate b. Value of n is this one, value of t is this one. Let's find t cross n. We have the value of b is equal to t cross n. Let's calculate the I, j and k. Let's place the coefficients of t. So minus 3 upon 5 upon 5 cos t, 4 upon. Okay. Now let us place the coefficients of n. So this is minus cos t minus sin. Okay. This is equal to I times of 0. This is 4 upon 5 plus j cap. This is minus 4 upon 5, 4 upon 5 cos t plus k, 3 upon 5 sin square t and 3 upon 5 cos square t. So 1. So this is the value of b. We have the value of b as value of b is 4 upon 5 upon 5 cos t j cap plus 3 upon 5 okay, the value of b. Let us calculate dB upon ds. So we have to find, we are left with tau only. Let us find the value of tau. How we can find this? So we have from the second expression of the Serret and Frenet formula, dB upon ds equal to minus tau n. So let us calculate dB upon ds. dB upon ds, this we can write as dB upon dt upon ds upon. From here let us find dB upon dt. dB upon dt we can write as 4 upon 5 cos t I cap plus 4 upon 5 sin t j cap. Okay, this is the value of dB upon dt. Let us calculate dB upon ds. dB upon ds we can write as this, we can write as upon dt upon ds upon dB upon dt equal to dB upon dt is this one, 4 upon 5 cos t plus 4 upon 5 equal to 4 upon 25 cos t I cap plus 90 j cap. Okay, this is the value of dB upon ds and this is equal to minus tau n. Tau into n. Let's place the value of n. N is equal to minus. So minus minus plus. So cos t I cap plus 90 j cap. This gets cancelled. So from here we have tau is equal to 4 upon. Tau is equal to 4 upon. Okay. We have calculated. This is our t. This expression. We have kappa as this one. Tau. Then this is this all we have to find in the first question. Now let us discuss question number 7. How we can solve this. Let us discuss question number 7. So for solving question number 7, 8 and 9, we will use the expression, that is expression for curvature and the torsion. The expression for curvature is given y is equal to dr upon dt cross r upon dt r का order upon dr upon dt का whole. Torsion is given by scalar triple product dr upon dt r upon dt q r upon dt divided by dr upon dt cross r upon dt square का whole square. Using these two expressions, we can solve question number 7, 8 and 9. So let us discuss question number 10. How we can solve this. Let's find question number 10. We have the question number 10. Solution of question number 10. Let us write down the position vectors. R is given by e to the power t I cap minus e to the power minus j cap plus root 2 t k. Let's solve this. So we have dr upon dt r dot given by e to the power t I cap plus e to the power minus t j cap plus root 2 r double differential to the power t I cap minus e to the power minus t j cap plus 0 k cap. And r triple dot, this is equal to e to the power t I cap plus e to the power minus t j cap plus 0 k cap. Okay, let us find the value of k. Okay, so for finding the value of k, so k is given by r dot cross r double dot mod upon r dot ka whole. Let us find down r dot r double dot r dot cross r double dot given by I j is e to the power t to the power minus r double dot e to the power t minus e to the power minus 0. This we can write as this is equal to I times of this is 0, this is root 2 e to the power minus t plus j times of root 2 to the power t plus k cap. This e to the power t into e to the power minus t, this minus 1. This is equal to the power minus I cap plus root to the power t j cap. Okay, this is r dot cross r double dot. Let's take mod. Here we have to find the mod. R dot cross r double dot. Modulus of this to the power minus 2 plus to the power 2 plus 4 the root. Okay, let's take 2 outside equal to root 2 times of under power. Let us write down this first. To the power 2 plus e to the power minus 2 plus is equal to root 2 times of this we can write as under root of to the power t plus e to the power minus t square equal to root times of e to the power t plus e. This is the value of r dot cross r double dot. Let's write down here. This is 2 times of the power t plus e to the power minus t. Now let us find r dot ka cube. So this is our r dot. Let's take the modulus of this. Modulus of r dot. Modulus of r dot is e to the power 2 plus e to the power minus 2 plus 2 the root. This is equal to the power t plus e to the power minus the root. This is equal to e to the power t plus e to the power minus r dot mod का whole cube power t power minus equal to upon e to the power t plus e to the power minus t. This is the value of curvature. Now let us find the value of torsion. The torsion is given by scalar triple product r dot r double dot r triple dot 1 r dot cross r double dot ka. This we have already found. Let us find the scalar triple product r dot r dot r double dot r triple dot. You can write as, let us write down the coefficients. Coefficients of r dot is power t to the power minus t. Coefficients of r double dot, this e to the power t and minus e to the power minus t, 0. Coefficients of r triple dot, so e to the power t, e to the power minus t, this will be equal to root 2 times of this e to the power t cross e to the power minus t. 1 is minus of plus 1 equal to divided by r dot cross r double dot का whole square, r dot cross r double dot, this is this expression whole square, so this is to the power t plus e to the power minus, this gets cancelled, this is same as this one, so upon e to the power t plus e to the power minus t, we have curvature is same as torsion and this is equal to root 2 upon the power t plus e to the power minus. Okay. Okay, so we have discussed up to question number 10. Okay. We have discussed total 10 questions on the problems of the Serret and Frenet form. This is all about the Serret and Frenet. Thank you.